left off this yesterday.
Still don't know how to do it.
Still don't know how to do it. Still want to kill myself. Shouldn't say
We're
that
not
again.
recording.
We're gonna get counselors. Just bring them here. Let's just move to our office.
This is a bad class for you.
No, she already has to be here.
All right, so in this, we had worked on finding this third force. Okay, force 3. We had found said force.
You found said force. Yeah.
We had no idea how to do it, and then you said slow down, and you said I'm on speed up.
We say slow down and you just push on the gas.
Oh god, now you'll see our struggle will be
You know how
mad.
they say like men have selective hearing? I think every time they say slow down,
He's like, look at
he's like no.
All right, in this case, everything that we're measuring though has got to come from this positive x-axis here. Okay. So all the angles that we're measuring from. So we have beta, but that is from the negative x-axis. We need that angle, which I call theta. That angle. D-A-T, that.
That angle.
That. Yeah. So in this case, we have theta is equal to beta plus 180 degrees, which can give us. You guys be like, we were that close to fixing that problem. Yeah, we were. This gives me 252.8079 degrees. So our grand Mad Daddy answer from this problem is force 3 is equal to 74.4307 newtons at 252.8079 degrees.
Yes, sir.
And there's your answer.
Good job, Mr. Hall. You did really good.
Question?
Before you move on.
What?
Take a picture of it. Can I write this down?
Questions?
Lindsay Walls, Dakota Brown, come to the office. Lindsay Walls, Dakota Brown.
Does anybody have?
So literally, all we did in this case is you had 3 forces going on. So we looked
Jordan
at those 2
Simpson, Caitlin
forces.
Smith, report to class.
We took this force because it does not fall, force 2 because it's not falling on an x or y axis. So we need to break it into the subcomponent vectors, which is what we did over here. We found y and we found x, and then from there got those values. Then we found the net forces happening for those 2 forces going on, force 1 and force 2. So we found the net force in the x direction,
I guess.
which is 22 newtons. And the net force in the y direction, which is 71.1051 newtons. So in that case, our third force is equal to in magnitude but opposite in direction to cancel everything out.
Yep.
So in that case, we just stick the magnitude of that number with the opposite side. Yes.
Freaking mint. I just, woo. I got it.
Hey, Julie gets it.
I lied. I have no idea what we're doing.
You sound really smart in front of Miss Harvey. Like really smart.
It's like, I get what you're doing, and when you do it, it makes perfect sense. But I have no idea how to do this by myself.
I've never been more lost on a subject than I am this one.
Yeah, same.
And I'm not being dramatic.
Like not
I have a tendency to be dramatic.
I walked in the class.
My
and
horoscope
immediately
said I'm
lost.
so bad.
It's like I understand how you're doing it, but I don't know why or when to do it. If that makes sense.
Okay, let's look at 82.
That's not going to help, Mr.
No.
I hear your struggles, but I won't address it. And we're gonna move.
And we're going to address it.
Selective hearing.
Okay. So let's look at 82.
5 forces. Ooh, we jumped up from 3 forces to 5.
Yeah, life just got real. So okay, so
Oh,
it is
just always?
Just now?
I have a quick question.
That's cool, ain't it?
Did your horoscope tell you
Why
about
did you
this?
put the assignments in Yes.
1, 2, 3.
Because we're gonna need them after this quick.
Is that why you did it?
Yes.
No, the reason I did it is
Don't even lie.
county policy is we're supposed to have like 2 assignments a week. That's what we're supposed to average out to. So I'm like,
And
man,
Miss Augenbach
not
could have
really.
27 a week.
That's great.
Nope, don't.
So like we get 2 assignments a week in here?
Yeah, we're averaging out to that. Instead of taking like all these book problems and I give you a point for every problem we've worked and just throw it all together, I'm breaking them up.
Yeah, so it's not like we're getting
So we're getting the same
We're
amount.
getting the same amount. But on paper, at the end of the year when they're like printing, I'm not taking one sheet and they're like, this is all your physics class did? I'm like, please. Listen, if you only knew what those kids went through.
I know this isn't English, but you know what that's called? I'll lose you.
No.
Alright, so in this, 82, 5 forces act on the object in figure 24. First force, we have a 60 Newton force at 90 degrees. Second, a 40 Newton force at 0 degrees. Third is an 80 Newton force at 270 degrees. And fourth is a 40 Newton force at 180 degrees. And then we have fifth is a 50 Newton force at 60 degrees. What are the magnitude and direction of a sixth force that would produce equilibrium? Okay, this is all you got to do. You're trying to find that sixth force.
Ain't it going to be that one that's like going to be like
I can show
the
you
other
where
side,
it's
the
at.
other half of like
Cross
that 50
elimination.
newtons?
It's gonna be negative.
It's going to be like, you know what I mean. But
In the third quadrant.
like you know,
I think it will be in the third quadrant, but I'm not 100% sure. I'm going to say I'm like 92% assured that we're going to be in the third quadrant.
because it seems pretty like logical.
Yes. But this is the
Force here,
thing.
force there, force there, force
This is the thing. When you're looking for a sixth force to cause equilibrium, what you need to do is find the net force that's going on within the system. Take the magnitude of those vectors.
Wait, stop. Go back to the before the magnitude of the vectors.
Find the net force of all 5 forces. Okay, so what we're going to have to do, look at force 1. It's on a y-axis. You don't have to break it down any farther. Force 2, on an x-axis. Don't have to break it down any farther. Force 3, y-axis. Don't have to break it down any
the
farther.
50 newtons.
Force 4, force 4 on the x-axis. Don't have to break it down anymore.
So
The
That
fifth
little-
force
You have to break it down.
comes
you
off
treat
at
it all
an
straight.
angle. You have to break it down into subcomponent vectors, so the x and y components.
So this is where you do the little
Tree.
triangle.
Yes.
The tree.
And then you add all the x forces together, and that gives you the net force. That gives you the net force for the x direction.
Okay.
Then you add all the y forces together, and that gives you the net force for the y direction. Then from there, you take those net forces x direction, net force y direction, take the magnitude of it, and stick an opposite sign. So if it's positive, we're going to stick a negative. And that's going to be the components for the sixth force.
Is that all? Or
Wait,
do you need it?
Once you do that, you get those components, then you do the Pythagorean
hold on.
theorem, you find the resultant vector. Once you find the resultant vector, then you have to find the angle from the positive x-axis.
Wait, 6.
Pause. Wait. Back it up.
When we nod, it doesn't mean we understand.
Wait,
It means
wait,
we
no,
know
once you
we're
add them all
doing
up,
it.
Right
And
when
you
I
get-
think we're done is when you add more to it.
Wait.
And you get the x.
You get what he says at first and then just keeps on and keeps on.
One day he's gonna be like, okay, irresistible. So you have the x and the y, like you added them all up. You said you make a. You make them negative.
Then you do whatever from the net force, whatever sign is there, you just change it. Because our sixth force to cause equilibrium must be equal to the net forces of all the 5 forces combined together in magnitude, but opposite direction.
So magnitude is just like that.
Just the number.
Okay.
But the direction is going to matter in this case.
Okay, but so once we get that, we don't have to do anything else other than find the.
Once you find that result
There's
vector,
always more.
and that angle, that's it. That's all you're doing.
I bet not.
It's a shame, but I don't believe. We'll keep on
What a shame.
So when it's asked for direction, you either tell it like an X or Y. Because it says what are the
Don't
magnitudes.
we will blindly believe Mr. Hall and he said that
Once you
the
find that,
magnitude.
once you find
when
the
he said
degree,
rebel,
that gives me direction.
What does like magnitude mean?
That's the number. So like the number for the force. Okay, so in this case, all right, this is what I want to do. I want to focus on breaking down force 5. Okay, so there's force 5.
Okay.
At 50, that's what was it, 50 newtons? Yeah, 50 newtons.
Oh, she going. Wait, I need my pins.
Okay,
60 degrees.
and it was at what angle?
60 degrees.
30, 69.
So y'all can use your 30, 60, 90 triangle if you want.
that?
Okay,
I don't even know how to use that.
or you can just jump. I'm gonna jump. Y is equal to sine of 60 degrees.
Oh God, I was just getting my pins out and now we've already done all this.
Times 50 newtons. Okay.
Dakota Brown to the office.
The reason I get that is because the sine of 60 degrees is equal to the opposite over the hypotenuse. So there's y. So all you gotta do is multiply by 50. So make sure I'm in degree.
That's what I was about to say. 50 square roots of 3 over 2. That's your answer.
Wait. Oh, yeah.
But a number.
Because that's not the easy.
So 43.3013 newtons is what I get for the y component, and then the x component.
Now I wrote it all in the same color. And I wrote the wrong answer. Oh my gosh.
You can ooh.
Cosine of 60. Cosine of 60 will be adjacent over hypotenuse, this angle at this side x. So we just need to multiply both sides by 50 newtons.
Yes, sir.
That'll give us x equals cosine of 60 degrees times 50 newtons. So 25 newtons.
You don't see it doing, but everyone on this side of the room is like going insane.
I have to see it. I
Do
can.
you add like these X and the X and Y all together?
Yes, we're going to add all the x and y's together. So in this case, we're going to be looking. We have to find the net force in the x direction. This is equal to all those forces going on in the x direction. So in this case, I have this, which is positive 25 newtons, and it's positive 25 newtons because that component vector in the x direction is literally going in the positive x direction. It's this one here. So it's going in that x direction. So then from there, the only other things I have going on, and I'm going to do this just so none of y'all freak out on me.
Well, ain't it just going to be 25 because those two cancel out?
Yes, that's exactly right. But I'm going to do this because force 2 is 40 newtons, and it's going in the positive direction. So it's positive 40. But then in this case, force 4 is 40 newtons, but it's going in the negative x direction, so negative 40 newtons.
Nice.
And they just cancel each other out.
That's nice.
To leave us with what Savannah was saying, we're just going to end up at 25 newtons. Now that is the net force for all 5 forces in the x direction.
Okay.
So now we got to find the net force
Oh,
y direction.
that's just the X.
So in this case, I'm going to start with this y up here that I solved for, the
Carrie has come to the office.
43.3013 newtons plus 60 newtons. So going in the positive y direction
But 80
plus
Well, that means it's important.
That is X and Y.
negative 80 newtons. I put negative because force 3 is at 80 newtons. It's going in the negative y direction. So in this case, add them all together. I thought, but didn't say it. Gives us a 23.3013 newtons.
Can we add them? No, we're not that far yet.
And then we find the.
Wait, we do add them?
No, we do not
I
add
was
them.
gonna say, I thought you said yeah, and I was like, no, that's not how that works.
Don't you put him in like do like Pythagorean theorem with it?
Not with these, ideally. I mean, you will, but not really.
You could put our cans on
I've not put y'all's yet.
Oh,
Yeah,
I
you
need my
have.
paper.
No, there's some, like, Taylor and Dylan brought me some. I just haven't put them in here. I got the notes still up here.
Okay.
Why, are y'all scared?
No, I mean, I have a day in here right now.
Fear,
but-
I look fear in the eye and I cry.
Alright, so you got these net forces in the X and
Fear
Y
it
direction.
is, and I fear it.
I look fear in the eyes of it.
So, we got these net components. Now, this is the thing that we're looking at. Let's put a Cartesian system up.
I have a funny TikTok to show you after.
Alright, so, going in X direction, that's 25 newtons, positive direction. So we're starting here at the origin. 25 newtons over. Then I got a positive 23.3013 newtons up.
That's what I just said.
I decided to go with it to show a relationship. So that orange force right there is the net force. That's the net forces of those 5 forces. So we literally have to have a vector that is equal to magnitude but opposite in direction of that. So in that, you're just looking like the mere reflection of it.
How did I?
So in that case, this is the 6th force. What is the 6th force component vectors? Okay, for the 6th force, so force 6, X component,
I have a question.
negative 25 newtons.
Wait,
And it's related to math, but I think it may help us in this problem.
Okay,
When you have triangles like that, they're supposed to have the same angles and all that jazz because of alternate interior or alternate exterior angles. So is that going to end up being the same as our 50 newtons, that vector, and then all of the answers are the same, but maybe in a different direction?
If
I
you're
want
trying to
to say
explain
yes,
this to
but I'm
us
not
like
100%
this, and we can do it like that, that's not fair.
but if you did that, do you know how many people sitting in this room would leave me with that net force? And guess what? That's wrong. Because if I apply the 6th force at that angle there, we would not be at equilibrium. We would be pulling twice as hard.
Wait,
Maybe we should.
So there's the, so the force 6, Y component, we get negative 23.3013 newtons. So in this case, your component vectors, so there's the first one, 25 newtons, and there's this one. Right angle, 23.3013 newtons. So we got to find 6 force. It's equal to the square root of 25 newtons squared plus. You don't have to. You're looking at the length. It doesn't matter anyway. You're gonna square it.
Oh.
It'll take it away.
Well, it kind of has to come out.
23.3013. If you want to put the negatives and do it.
Is this the distance form?
It has to be. No, it's Pythagorean.
Pythagorean theorem. I just jumped.
He just jumped. He forgot his C squared.
Oh.
Square rooted of it. You always skip this.
I do, because look at y'all. Y'all are like the top-notch students. Y'all are like jumping on board. You automatically knew what it was.
Okay.
But
But
the best you're all.
I'm definitely. It looks like the distance formula.
When I'm in math class, you understand.
Taylor, I thought we agreed that I was
So, 4 6 is 34.1753 newtons.
Like how you all think
And that's what I just did. So you can see that.
Don't you have to find the angle?
Yeah, we gotta find that angle. So, sticking with popular demand,
Well, he's just gonna say it anyway.
Now,
beta. Let's find beta.
is that our hypotenuse?
What?
The 34?
Yes.
Yes.
Okay, but that triangle has the same x and y as the other triangle with a 50 Newton hypotenuse.
Yeah.
Why are they different?
50 newtons.
Yeah, the first triangle we didn't it have like 50 Newtons as the hypotenuse?
That's the net force. That's
Net
different.
force. Ah, I got it.
Yeah.
Yeah, it was
There we
different.
go. Alright, so we gotta find beta. So beta will be equal to, let's put y'all to the test.
no.
But why are we
Why? You know we're not going to get it right.
I don't know why we just can't use
23
Yeah.
over 24.
Once y'all watch Tom Theard, you would get my references to that.
Until then, we'll
So we gotta find angle beta, which is just the inverse tangent.
Oh,
23.3013 divided by 25. Close that up. So we get 42.9858 degrees. It's not the end there.
34.
That's not
that
the end.
Now,
number
Mr. Hall,
at
you remember about 10
42
minutes ago when you were like, oh, this is all you have to do for this problem. That was 10 minutes ago.
I never said was gonna
Emily
happen.
Painter to the office, please. Emily Painter.
wasting the lives of trees.
So we gotta find that angle. Call it theta. Theta is equal to.
Wait, where did theta come from?
You gotta have the angle from the positive
We're not-
x-axis.
But why?
That makes so much sense.
You have to have that angle because in terms of every angle you're being given is coming from that positive x-axis. So whenever I look at you and I tell you apply force 34.1753 newtons, that gives you magnitude, but you need direction. The angle gives you the direction.
So wouldn't that
180 plus the 42.
58?
So I have
Why
to
wouldn't it be that?
Wait, what angle are we looking for?
Because
We
that
like-
is, there's a fancy term for it, trig.
That's 180.
Wait, no, wait,
Yeah, we're
what
gonna add
angle?
180 to it.
What angle are we looking for? Like, where is it on the
Theta.
little thingy? All the way up there?
It's
Like,
not
in the
180,
corner next
it's
to the
180
origin.
plus
180 minus 42.
Oh, wait, you didn't say your
Plus
Like, that's the
42.
With 90 degrees.
I thought he was going from like along the flat.
No, wait, you tell you.
I'll let you continue. So now
This
I
is
gotta draw
fine,
my
this is fine.
thingy
That's
farther around.
okay.
That looks like
So
an
we're
eagle.
looking for the purple line.
Purple, it's
Weird.
Yeah.
That
And now we put the
You would have told me
34
that, I would
thing
have.
at this number.
So then we look and go 4 6 is 34.1753 newtons at 222.9 9, 8, 5, 8 degrees.
Why do we have to do that? That one wasn't so bad.
What?
We had like a worksheet full of these. We
You
might
got a
be able to-
Katie, you literally
Together.
none of us had any idea what we were doing.
But if we working together.
We had a worksheet with
I liked it better when you were the one crying and not me.
I know, and that's the thing. It's really fun because then we're gonna break everything apart. Like we still haven't put a box on a ramp without with friction.
Do you have another problem like this we could try together
Yeah.
without you in the equation?
God,
So I
no,
know
why,
if I get it.
Y'all, while y'all doing that, y'all know how we worked out the one before.
y'all know the TikTok.
You didn't know how you got it right. You just added numbers together. You're like, that looks like a good answer.
Y'all know that TikTok is like, why you keep going like that? I'm trying to get it to go like doop, and it keeps going whoop.
Why you going so fast?
Yeah, you got one like that.
No, like
83.
one exactly like that, but like with different numbers.
83.
Can you put 83 up there?
That's not the
Like
same.
the picture on the
Who wants to use the whiteboard?
Ultimately, you're looking at the same. You're not trying. You're.
I'll go up there.
It's a little bit more than that.
I'm going to the whiteboard.
It's not exactly the same, but it's the same concept.
Okay,
Oh my goodness! It's about applying concept.
Why do you do it like that?
This is not math involved.
Go.
I'm getting the board.
No, we
We're
don't.
literally so
Where did you get
Can I erase this or is it?
high
Hey,
ever.
that?
Now, remember when you said this isn't Breaking Bad? You're out here writing Heisenberg on the board.
That's where his name came from, but I'm actually talking about the real scientist.
Essentially, Mr. I got it.
All right, look, I got faith in y'all. Y'all can erase that. You can erase that 4 quantums. Just leave those numbers in the lower left for me.
Now, Mr. Hall, you had faith in us when you left us in wrong 72, and then you got back and you said you were disappointed.
I was extremely disappointed.
You're like, I don't know what's wrong with you.
Joe wishes to hang a sign weighing 7.50 times 10 to the second Newton so that cable A, here's cable A, attached to the store makes a 30-degree angle, as shown in figure 25. Cable B is horizontal and attached to an adjoining building. What is the tension in cable B?
Okay, guys.
tension is very high.
Get a draw like this.
Okay, well, that the A is like if this is your y-axis, the A is like coming out of the origin, I think.
Yeah,
Right?
that's
And
like
there's
it's coming
gonna be
out
a
of
line
my
right
arm,
there.
but not your eggs.
Is that correct, Mr. Hall? Tell us if that's correct.
Guys, I have a book right here. What am I doing? So
If I was you, this is what I would do.
I would draw a line straight
Sorry, that
up.
was wrong.
one color.
What? Oh. Yeah, that's what I was about to say. Is
That's
that we
what-
need to make it look
X-axis.
like the
I
problem
was trying to
before.
articulate.
And then that's what Julie was attempting to
That's
say.
what I meant.
I'm trying to draw it in the.
I was like the thing, the
Y-axis.
so look, the this.
That's not
The this.
Thank you. That's what we were. That's what she was saying, and that's what I was mumbling
The
about.
this. I don't know.
The hypotenuse thing.
Miss Hargis is laughing because she knows we're dumb.
I don't know. I got an A in here, but not in there.
I'm giving you a color by number for your snow packet for browns.
Thank you so
Oh,
much.
yes.
Can you give us a color by number for us?
And then I have to draw
Nothing, don't worry about it.
So you have to
Okay, now the second quadrant's got like a little thingy. No, this is straight out to the left. What about that thing that you said about 30 degrees?
Which one's 30? From here? Got to draw something right here?
The up corner.
Can I go to the French room?
The up corner.
Which makes this
The
angle
corner, no,
60.
the corner like on the inside, but on the up.
Okay,
Down.
Chloe, drop a line.
Yeah, drop
Right
it
here?
Yeah, drop a line right there.
Okay, that's right.
And then in the top left corner, it's 30 degrees.
Up ankle.
I said the up corner.
Drop a line.
We were like, no, the
Okay,
Up
up-
angle.
and then up at the top corner, it's 30 degrees.
Yeah,
30
right there.
degrees, and then it's 60.
and then the
okay.
right, the 90 degrees on the little corner. I got that. I can draw a triangle.
And then 60.
You don't have to put 60 because it's not up there.
Yeah, it's not. It's
Yeah, don't put
irrelevant.
60. It'll make me nervous. Don't do it.
Why not put 60?
I'm not.
It's going to make me nervous.
What are you doing? What are you doing, dog?
Dude, what are you doing?
Let me
The other side. The triangle.
Where you did? No.
there. You guys need to support her.
Wait, Ginger, I like how she said you're beautiful, not you're smart.
That's how I felt.
Anyway,
Miss Powder's about screaming. She walked by
what is the tension in cable B? Well, B is going his way.
Well, first of all, how do you think your teacher?
Can we just
And A is directly across
This is
from the
ours.
right angle.
Yeah.
Yeah.
mean, this
Yep.
is
On the
ours.
triangle.
On the triangle.
Like the opposite.
hypotenuse.
Like in Soka.
Oh.
Yeah. Like in Sokotoa where
In the
opposite do.
hypotenuse.
Okay.
Okay, now.
Joe wishes to hang a sign weighing.
Piece of information that.
We gotta change that 7.50 times 10.
Yeah.
We gotta change
Do you have to use gravity in this happily? Or am I wrong?
Wait, let's read.
Well, I did read it, and I think it might be
That was
gravity.
weird. Put your hand on the book again. Ooh, what does that look like?
Do it again.
Just one.
Anyway,
do it, Chloe. Heard you.
Joe
It's called
wishes
Joe's,
to hang a
like,
sign. We need to read the problem and look at it carefully, and then we'll
Stick
talk
your head
about it
underneath
from-
that.
Okay, is A the 7.5 times 10 square newtons? Is that A?
He wants to hang a sign weighing.
What an
back.
awful way to hang up a sign.
So that cable A attached to the store. I'm thinking it's our Y.
Okay, guys, so this is what it's going to be like.
He lied.
Well, thank you.
Were
Chloe.
you making a sign?
I'm thinking, would it not be our Y?
That would be your math. Like, no.
Would that not
Okay,
be?
but
Would that
I'm
be your
trying to find
maths?
your B, so it has to give you either A or B.
Wouldn't
And
that
you're
be
trying to
math?
find B, so I assume that's A.
Mr.
but
Hall,
we're not
wouldn't that be
assuming
math?
this class.
Well, it says it
Thank you
weighs
for
that,
coming
so cable A would make 30 degrees.
If we have to
I
find the
know
tension
that, but like
in
remember
cable B.
that last time you said something about.
Touche.
You don't go on Newton's.
I don't know.
Well, never mind.
You moved the book.
I don't know. You said something.
I know, hold on, guys.
What are you trying to do?
Find figure 25.
That-
We're looking at
that is
finding
figure
you.
25.
Not figure 25, but find an example problem.
Why don't we just go to the back of the book?
My gosh, I'm like getting intoxicated just watching this.
Hey, Mr. Hall, at least we're not like East. At East, they get inside that thing and shut it. Okay, at least we're trying.
Woo!
Like,
Okay.
and there was a video on Snapchat. I keep climbing that.
Attached to a sword
shut
that
it.
makes a 30-degree angle.
What is that?
Few minutes.
What?
Few minutes.
So that's the weight.
So do we have to change it to mass?
That's nice.
But wait, but it's Newton, so that means it's force.
No, he looked at her. Are you?
No, he underlined Newton's and shook his head no.
So wait, but if it's Newton's, it's force, correct?
Yes, Newton's has
No,
no force.
it's
But
force.
you have
But that's weight. Weight is different than mass. Mass is killing. Fix the book.
It's not.
Well, you know what I meant.
She's going through my notebook like I solved it already.
I'm looking at your other problems.
Well, you see, Chloe, if we can't solve this one, I don't
I
think we
think
can
it's
solve
weight.
the other ones.
You have not used this yet. I will look at you and tell you
Oh,
you're on the right track.
What?
Oh,
I remember whenever you did one of those problems on the board, you said something about
wait.
it being
So we
like
have to
weight.
use a triangle. 30. I bet we have to do like
It about being
like
weight.
sine, cosine, cosine.
Yeah, you gotta do sine, cosine, something times 30 degrees.
But we
No.
don't know what the
No, look what we did in the last problem, guys.
Like the sine of 30 degrees multiplied by something. What's yours?
Yeah, Mr. Hall had so much hope in us about. He's like, well,
Are you?
It's
We need
weight.
to make it like
It's this one. Okay, that works.
so you can crawl.
What is weight?
Yes.
Not mass.
weight is your force on something, correct?
I'm getting dizzy, Colin.
And the G.
Force of gravity.
F of G is weight.
So you do have to use gravity, or am I wrong?
Gravity? Is it gravity?
No, you don't need gravity because they already gave it to you.
Okay.
Coming off, free body diagram here. Coming off here, you got the force of gravity.
Wait, we need to.
What other forces are we
Normal force.
facing?
Normal.
Normal force.
I like how you're thinking, but look. Look at the sign. Is it on a surface?
No.
So can there be a normal force?
No.
The normal force is not there.
Okay.
So what other forces are you facing?
Billy, did you say
The weight of
Got the weight. So right here, what's the force you're looking for?
B on the rope.
Force of tension B. So tension B. Tension is a force. So you can put force of B there if you want. Then from here, the other thing you're dealing with is this. Somebody jacked my page up, not naming names there. Chloe.
I didn't know such thing.
Wait, what do you want me to do?
And then you got this force. Can you stop moving it?
Oh, you lined it up perfectly before you moved.
Y'all, I could be entirely incorrect here, but if you're looking at this psychologically, wouldn't the sign not stay there? Wouldn't it just keep sliding down the rope? Or am I crazy?
It would, because it would go.
Here's the thing. You have the tension of A.
Give me a second.
Is there any other forces?
No.
No, you have gravity and that's it. And then yeah.
The tension of these cables holding the
Okay,
sign.
well, yeah, but okay. Yeah.
Okay, so that's it. So deduce from this what you can. What's the tension of B? In what direction?
Wow, X.
X. So there has to be something. This tension is pulling this way. Is that sign being pulled into that building?
No.
So there has to be something that's opposing that. What opposes the tension in B?
Shine Jenkins, Tyler Mullins, Haley Rowe,
The negative.
Chase Short in the office.
The negative tension of B's.
The negative. Yeah.
Alright, do that then. Sure.
All I did was
You said the.
The X component of the tension of A.
Okay. That's it.
So you have the tension of A,
Yes, sir.
X component.
Tax.
In this case, that cancels these two out. So now, it's not moving in the X direction. Is the sign moving in the Y direction?
No.
No. So in this case,
Friction.
there has to be something opposing the force of gravity.
The friction.
Opposing weight. What is opposing weight?
The A is pulling it up. Or no.
Friction.
Tension of A in the Y direction.
Friction.
Which says that this and this is equal. They gave you weight in the problem. So weight is equal to 7.50 times 10 to the second newtons.
And there's no normal force.
Because it's not on a surface. Remember, normal force is always perpendicular to the surface. It isn't on a surface. So, put my purple marker up. Quit it. Quit giving up. So in this, what can you say? Tension of the force of A in the Y direction is equal to 7.50 times 10 to the second newtons. Since you have that, you have an angle.
Oh, okay, I see now.
What is opposing the tension of B?
It's 30.
A. No. No.
So in that case, to find the tension of B, tension of B is equal to tension of A in the X direction. There's your identity.
That's me.
Mr.
What?
Hall.
That's 30,
Yeah.
not 60. So tension of B is equal to tension of A in the Y component. Now you can solve the problem because you now have the identity and relationship
That's not
that you can solve for. You can solve for this. How are you going to solve for that?
I'm getting the tension of B. Oh, wait.
Solve for the tension.
That's something that's really
The tension of B is the same 0.5 times C.
Red one?
Yeah.
Tension of A in the y direction is equal to, so I'm looking for this right here, I have this angle.
That equals 7 point.
Hey, wait a second.
Because that's what you wrote up there.
That's X. I meant to put X.
Aww.
Tension of A in the X direction is equal to tension of B. So in this case, I gotta find tension of A in the X direction, tension of A in the X direction. It's a whole lot harder to do on this board. Is equal to, so tension of A, there's opposite. I have this, which is adjacent. So whenever you're looking at it, tension of A, opposite, adjacent. So tan of 30 times 750 newtons. You do that, gives you tension of A in the X direction, which will ultimately give you the tension of B.